This week we will discuss more about variance reduction technique. So I will introduce two very nice approach that can reduce the variance of SGD algorithm, and one very popular application of variance reduction technique, which is reinforcement learning. In reinforcement learning, we can apply our main idea, how to reduce the variance of your stochastic gradient, especially for Polish gradient method. So in this week, I will explain two stochastic gradient descent method with variance reduction technique, and one Polish gradient approach that can reduce the variance from the idea. Okay, so what is variance reduction? So basically, the variance definition is this. Variance of x is equal to expectation of x minus expectation of x squared. Variance reduction technique is for the case x has very high variance by introducing some auxiliary random variable y. So when we add minus y and add expectation of y, we can keep the expectation. Okay, I mean, if our expectation of x is equal to what we really want to use, like a gradient of our objective function, then we want to keep the expectation because we want to move our update to the direction of gradient descent if you want to optimize your objective function, for instance. Okay, so even if you add something or subtract something to reduce the variance, if we follow this rule, when you subtract something then add something in expectation sense, then we can keep the unbiased property, right? So what I mean is, when you take expectation, then this is equal to the original expectation. Okay. Then what about the variance? The variance of x minus y plus expectation of y, that basically equal to expectation of x minus expectation of x squared plus y minus expectation of y squared plus, no sorry, not plus, minus 2 x minus expectation of x, y minus expectation of y product. Okay, so this is equal to variance of x plus variance of y minus 2 times covariance between x and y. So if x and y has positive correlation and the variance of y is not bigger than variance of x, then we can expect that this term is negative, and so the variance of x minus y plus expectation of y is less than the variance of x. Okay, so if we can introduce the random variable y that has positive correlation with original random variable x, then with this technique, subtract the random variable y and add the expectation of y, we can keep the expectation, so we can keep the unbiased estimator if X was unbiased estimator. And also we can expect the reduced variance.